Let's have a look at this circle. Label at A, B, C, O. This line here passes through the center of a circle. Therefore, it becomes a diameter. Now, we say the angle at the center of a circle is twice the angle at the circumference. So it's obvious that angle AOB is 180 degrees. Therefore, this must be half of 180, which makes that angle a right angle. So, and because AO is a diameter, it's cutting the circles into two halves, two segments which are equal, semicircle. This is half a circle, and above AO is another half a circle. So we say an angle in the semicircle is 90 degrees. The angle at the center of a circle is twice the angle at the circumference. So this angle here subtended by the diameter is a right angle. That's 90 degrees here. Now, I want us to have a look at another one. Before we go to a proof of the angle between the chord and a tangent is equal to an angle in an alternate segment, let's have a look at this one here. This one will go there. No. And have an angle that goes through there. And we can move here and go up there. And then we can label this angle here. Can say that one is A, angle O, and then that one B, and then call this one R, P, and this angle here is 135 degrees here. 135 degrees. The question here is to find angle R, angle P, and angle Q there. Angle R, angle P, and angle Q. Let's Q there. Now, from our diagram there, angle P must give us 45 degrees. We say angle P plus 135 degrees is equal to 180 degrees. And the reason is that the straight line, a straight angle is formed there, straight angle. Therefore, P is equal to 180 minus 135, and that will give you 45 degrees. Angle P is equal to 45 degrees. Now, let's say P here is 45 degrees. But if you look carefully, Q is at the center of a circle. If you look at A, P, B, O, and A, therefore it makes Q to be 90 degrees. Now, this angle here is an angle at the circumference of a circle from this purple color here, and therefore this angle R must be half. Therefore, we say Q, angle Q is equal to twice angle P, which is twice 45, which gives us 90 there. Therefore, but angle R is half, angle Q is going to be half of 90, which is equal to 45 degrees. Now, if angle R is equal to 45 degrees, and then we have I hope you realize that angle R is equal to angle P, and the reason that they are subtended by this arc here, or you can just draw a line from here to here, a chord from A to B, comes a chord there. Therefore, angles subtended by the same chord are equal. Therefore, AB subtends R there in the same way it subtends P. That's why P and R are equal. We are going to have a look at this diagram here. And then here we have a line that will touch a circle at one point, and that kind of a line is called a tangent. This is a tangent, touches the curve at only one point. It's touching a curve at a point. And we call that tangent. Now, here, we would like to prove that this angle here, this angle between the chord and tangent, AB is the chord and CAD is a tangent. AB is a chord, and then CAB is a tangent, is touching the curve at a point. So we want to prove that this angle here is the same as that angle there. Now, examiner will give you 4 to 5 marks for this proof here. From here, we are going to draw a diameter. A diameter will, from here, we draw a diameter to pass through the center of a circle. And from here, we'll draw a line going this way here. Now let's see what do you know, or what you can just use from, or realize. What you can notice here is that angle, let's label them first. Let's label them first. It's E here. It's F there. And that will be circle center. This angle here and this angle here make up 90 degrees. Diameter and tangent. And then this angle, if this AE is a diameter, it means this is 90 degrees as well. You have seen that in the previous page. We said the angle at the center of a circle is twice the angle at the circumference, or the angle at the circumference is half the one at the center. If the one at the center is 180, this one 90 degrees. And then two things that we have seen. We have realized 90 there. We have realized another 90 here. Now, you also can see that AB is a chord and its substance F and E. So F and E are equal on the same chord there. Now, we continue with our proof. We write that as 1. We write that as 2. BAD is angle 2. Angle EAB is A1. Angle BAD is A2 then. Now, A1 plus A2 is equal to 90 degrees. Therefore, A1 plus angle A1 plus angle A2 are complementary. They give us 90. Therefore, angle A2 is equal to 90 degrees minus angle A1. Supposed to be A1 there. A1 here. Angle A1. Now, in this triangle EAB, angle E plus A1 is equal to 90. 90 plus 90 give us 180. The sum of the angles of a triangle is equal to 180 degrees. Let's say triangle E, A, and B with angle B equal to 90. Therefore, angle E plus angle A1 should also give us 90 because angle E, A1 and B is 180 degrees. So we can write angle A1 as, we can write E as 90 minus A1, angle E plus A1 is equal to 90. Therefore, E is 90 minus A1. E will be 90 minus A1. E will be 90 minus A1 because if we add angle E to A1, you get 90. But 90 minus A here, the same as 90 minus A there. Therefore, angle A2 is equal to angle E because they are both equal to 90 minus A1. But again, we knew that angle E is equal to F, and you say subtended by the same chord AB, chord AB. Therefore, you can see that this angle here is equal to F, and this angle here is this angle here. Therefore, angle A2 is equal to angle F. If you look at the diagram, we said we wanted to show that this angle here between the chord and the tangent is equal to that angle in an alternate segment. So we say the angle between the chord the chord and the tangent is equal to the angle in the alternate segment. This is what you have. So let's put reasons here. We said angle A1 plus A2 is equal to 90. And the reason was diameter and chord. And then A1 plus A angle E plus A1 is equal to 90. And the reason here is that angles of a triangle equals to 180. When this is 90, it means you're left with 90, which is E and A. So that's what you have. So you have succeeded in showing that the angle between the chord and the tangent is equal to an angle in an alternate segment. Okay. Now, let's have a look at an exercise that says something to that effect, that the angle between the chord and the tangent is equal to an angle in an alternate segment. I'm going to say this more than once so that you are able to get that into your head. Let's have a look at this diagram here. Right. We have a tangent here. The tangent there. And we have a line going up there. We have a line going up down here. The line going up there. I'm going this down here. And we should have one going down here once more. we should have this angle here as 105. And this one here is 40 degrees. Now, and then let's label that as TU, and then ST is a tangent at T. You can see that's a tangent at T. BC is equal to CT, and angle ATC is 105, giving a diagram there, and CTU is 40. Calculate stating. Calculate given reasons. The magnitude, the size of one, angle A1, B2, angle O1, angle O1, and B2, angle B2. So where's angle A1 is this one here. Angle O1 is this one here. Angle B2 is this one here. Now, if this angle is 40 and is between this chord TC and a tangent, it means this angle here is also 40. Angle A2 is 40 degrees. Reason, chord, and tangent, and tan. Now, you know that this one must be the sum of the angles of a triangle, and we are given that CT is equal to BC. Now in triangle ABC, we have BC, and in triangle TAC, we have TC. TC subtends 40 here, and AB will subtend this. This must also be 40, subtended by BC. Therefore, angle A1 is equal to 40. subtended by BC. Now, let's talk about this here. Let's talk about that there by drawing. Let's draw it somewhere here. When you say, and let's label that triangle. A, B, and C. We say AB is equal to AC. Now, AC will produce this angle here. BA will produce this angle here. Now, these two angles are equal because BA is equal to AC. And we said this is a isosceles triangle. Isosceles triangle. So these two angles here are equal because they are subtended by lines that are equal. So BC here is equal to AT. We could have said in a better way, we could have named this one here B, this one here C, this one here T. So we say BC is equal to CT, is given up there. Therefore, the base angles should be equal. This angle will be equal to that. They are just subtended by those equal lines. BC subtend theta here, which is T, and BC subtend B here, which is theta. So that's how we argue that. Now we have done A. We can do O2. Angle O2 will equal to twice angle A1, which is equal to twice 40, which is 80. And the reason is the angle at center. Angle at circle. Angle at circle center. It's twice the angular circumference. Now we are left with B2. B2 is this one here. Now, this angle here is 80. And then this makes this angle here 50. This one here, 50. Because this circle center, it means this BO is equal to OC. And then this makes isosceles triangle again. But this angle here plus this angle here, these are opposite angles of a cyclic chord. They must give us 180 degrees. Opposite angles over cyclic quads are supplementary. Therefore, B2 plus B1 plus 105 must give us 180 degrees. Therefore, we say B2 plus B1 plus 105 is equal to 180. And the reason is that opposite angles of a cyclic quad are supplementary. Therefore, B2 will equal to 180 minus 105. B1 is 50. This is 180 minus 155. And this must give us 25 degrees. Therefore, B2 is equal to 25 degrees. We have solved number 3, the unsolved O1. That was O1 there. Hope you saw